Hello and welcome to this edition of the Step 7 Odyssey project. Today we're going to create some data blocks and do some work on simulations. In the last video we created these FCs and separated some of our code out into them, and this is in preparation for writing a routine that simulates a small machine, and we're going to keep expanding on this program. But in order to run this small machine, we're going to need to do some simulation, since I don't have a real machine, of course, to connect up to. So I'm going to use some data blocks with some simulated inputs and outputs to simulate this machine and drive it from another function. So to do that, the first thing we need to do is create a data block. Data blocks are created the same way that FCs and FBs are, and OBs. Simply insert them like this. And we're going to go ahead and number it something a little bit higher than DB1. And I'm going to call this Sim for simulation. Actually, maybe I'll call it Sim.io. So there's a lot of different things that you can do inside of a data block. You can put different types of data and mix them together as needed. You can put arrays of data, that sort of thing. What I'm going to do here is create some inputs, and I'm just going to call them inputs. And we will make this an array of bytes. So there are elementary types. These are all the basic types of data that you can create, and then there are complex types. So in this case, we're going to do an array starting from 0 to 9, which makes it a 10-element array. And we backspace over the initial value. There is no initial value, and we'll backspace over the comments. Actually, I'll say digital inputs here. That's a pretty good descriptive comment. So after you create an array and you hit enter, you will get a field like this, and you're going to define an array of what? And I am making this bytes because Siemens I/O structure is in bytes anyway. So what I'm going to do here is use inputs dot or square bracket 0, dot 0, dot 1 through dot 7, just like as if it were regular inputs. So after you've done that, if you hit enter, you will get another field. We're going to do the same thing for outputs. And you can either type this in or select it. It's probably a little quicker to select it. And once again, 0 to 9 and digital outputs. Now analog is also in bytes, but I'm going to do the analog a little bit different. I'm going to put them in Word format as if they were already converted. And I'll just call this a input. And we will make this also an array. And usually your analog process input words are in the higher registers, but I'm going to go ahead and number this, I suppose, just to show you that it's different. I'm going to make this one from 1 to 10. You do have to type this in exactly this way, 1 dot dot and whatever your endpoint is. This is kind of a nice feature for Siemens, that they'll allow you to start at 1 or 0. And we're going to make this an array of integers so that we can do math with them. If I made this an array of words, we would not be able to do math. So this isn't strictly in the same format that actual analog inputs and outputs would be in. They would be in bytes. So these are going to be sort of as if they were already scaled into a raw number, but we're going to treat them as if they were scaled from 0 to 32,767. So basically a raw 4 to 20 or 0 to 10 volt signal. And once again, we'll make this integers. So we have 10 input integers, 10 output integers, 10 input bytes, 10 output bytes. And we are going to save this and close it. Actually, before closing it, we're going to view this in a different way. I'm going to view this in data view. So this is what our actual direct outputs would look like. So if I wanted to use one of these input bytes, I would have an address like inputs 0.0, inputs 1.4, something like that. Outputs 4.2. Analog input 2, and of course it would just have a number in it like 4,000, something like that. So that's kind of what it would look like, right? And I would get my values directly from my processor. So we are going to save this. Okay, it doesn't like that, so we're going to put a 0 back in there, and then we're going to save it and close it. And I could have downloaded it from there, or I'm going to download it here. So just select it, download it, and let's take a look and make sure that all of our blocks did get into our processor. And I did download these blocks ahead of time, and you can see the data block here. Since this is a data block that's nothing's been done to yet, I can actually monitor it here and view the data inside. If I wanted to change it, I could. And so we'll be using some of these inputs and outputs as needed. What we're going to do is simulate these and turn them on and off from another routine. So I'm going to create the other routine, and we're going to call it, and we're going to make it also a higher routine. I said generally you don't want to open blocks from here, and that is still true. So I'm going to close this. You want to open everything from the offline view and then go online. So there's a difference between this view, looking at what's in the processor, and this view, which if I open a block, I can look at what's in the processor also by hitting the glasses. That is a different thing than opening the online block and looking at it with the glasses. Let's create another FC here. In this function, we're going to go all the way up to function 20, and I'm going to call it simulate. And what this block is going to do, this is going to be the block that runs different timers and things and feeds back, turning on and off the inputs and outputs in response to commands from these routines here. So once again, we've created this. We'll download it, and let's quickly call it. There's all of our other calls. Simulation block. Make sure everything's running, everything's happy. Go back over here. We don't have any faults, so everything's good. And now we can actually start doing some programming. Now typically here, looking at these routines, what I would usually do is map all of the inputs and the outputs in, create their structures as needed, and then write my sequences using those inputs and outputs. But I think we're going to do that a little bit backwards here. We're going to write a pick and place sequence, and I'm going to grab inputs and outputs as needed, and then we will put them in the inputs routine and the outputs routine. I may need some other blocks here, so let's think about this for a moment. I'm going to pause the video and come back, and we'll talk about exactly how to do the sequence. Okay, after a short pause, coming back, I think what I'm going to do here is we're going to create a simple pick and place sequence where we pick up an object that's delivered by a conveyor and drop it off, perhaps to be inspected, and then shoot the product one way or the other on a conveyor belt. This is very similar to my old training machine in my old shop. So we're going to use sequence 1, and we're going to do that. First thing to do is go out of monitor mode, open up sequence 1, and if I were designing a real project here, I would probably create a lot of the addresses that I was going to use in a data block. However, here, since we're kind of doing this on the fly, I'm going to use just M bits for this, and we're going to kind of use them as they go. So one of the first things you do whenever you write a sequence is you need to start the sequence with some kind of a bit. You will make sure that you are in auto cycle, which we already do have an auto cycle bit. And then I'm going to do what's called a numerical sequence. So I'm going to use an equal statement and create some of these bits on the fly. I will find the equal statement down here in the comparator. This will be equal integer, and we will say our sequence is at memory word 10. I don't think we've used anything there. So if memory, we have used it. Okay, so that's another reason, again, why we name things, because we can tell whether we've used things or not. I did this in the data table, in the symbol table. So I'm just going to type in another raw number here. Let's try memory word 20. And I'm pretty sure that hasn't been used, and we're just going to name this pick and place sequence. So PNP sequence. Give it a nice comment. And we'll make this an integer. Again, the difference between an integer and a word is that I can do math on integers, and I may need to do math. Who knows, maybe I have to add something to it or whatever. So I'm going to keep it in integer format, and we're going to say if the pick and place sequence is equal to 0, then we are going to allow the sequence to start, and we'll just come up with a nice address here. Another good thing you can do here is go ahead and go to your reference data and see which bits have been used. We'll regenerate everything. And we will look at the assignment. And these are the bits that we've used so far, but of course we did name some things before. So I'm going to open that up also here. Take a look at some of the symbols. And there's what we've used so far. We've used memory word 20 here. We've used 10, 12, lots in the 100s and 200s. So I have quite a few bits here, say from 14 to 20 to use as needed. So I'm going to go ahead and put a quick bit in here, and then we're going to end this video. We're going to use M14.0. And we know that hasn't been used yet. And I'm going to call this pick and place trigger. And we will make that actually driven by something later. Come up with some way to start the sequence. So this is kind of how you can program on the fly. You don't really need to worry about exactly what drives this yet. So this is step one of creating a sequence. We want to do a move. And we're going to move 10. So you want to skip numbers when you're running a sequence. So for instance here, something happens and I'm going to move 10 into the pick and place sequence when the trigger happens. The reason we skip by 10, so I'm going to say if 0, something happens, move 10. If 10, something happens, move 20, and so on. And the reason for this is it allows you to put steps in between these other steps. That's why we go by 10. Same thing you do in what's basic programming. I'm going to end this video here because we're kind of well along in it, and continue this in the next video. Thank you.